I mean, I think that.
Can you all hear me? Yes, I can hear myself. Can you hear me at the back? Yeah. Good. Good. Good afternoon, distinguished guests, ladies and gentlemen, and colleagues. On behalf of Middlesex University, and particularly the executive, a very warm welcome to this special occasion, Professor Wynne, I think, inaugural lecture. My name is Anne Waddington, for those of you who haven't met me. I'm the Interim Pro-Vice Chancellor for Research and Knowledge Exchange here at the university. An architect by training, a cultural geographer, and a professor of design innovation, which is really a professor of making plans and getting them done. That was how I described it in my inaugural. And that's what I got my professorship for, I think. It's a real honour, and it's always an honour, I think, to be here this afternoon, and it's a really special occasion in Inaugural. We bear witness to, I think, a relatively new professor. You have been a professor for 4 years, but a professor crossing, I think, what is a really important threshold into a somewhat new and I think different role. I think the professorial role is a shift. It's a shift in everybody's career. It's the pinnacle of many careers. So I congratulate you personally. It's really lovely to be here. You take on a role, I think, as an intellectual leader in your field, and in this case, Professor of Digital Communication Engineering in the Faculty of Science and Technology. But you also become an advocate, I think, for the university, and that's really also a really important role, that you stand proud in that situation. So such occasions are a rite of passage, and an opportunity for the community of the university, and indeed the public, in a broader sense, to learn about the achievements of our professors in research, in innovation, in engagement, and in teaching. And certainly the difference they make to society, and indeed within their community practice. So I am particularly intrigued today to learn about the digital transformation journey in areas of communication and indeed digital twinning, and how our lives have been and will be influenced by it in the future. But as you can probably tell, I come from the arts and humanities, broadly speaking, but I'm not an expert. So I thought, well, I'd ask a digital expert to write me a limerick of what I've just said. And this is what they came up with, and I thought I'd just share this one with you. Professor Wynne stands tall. With warmth, Anne Waddington welcomes everyone to witness his inaugural call. As the interim Pro-Vice Chancellor, she raises this grand ambassador, crossing thresholds anew as a leader so true. In digital engineering, a challenger. In science and technology's domain. Professor Wynne will explain the digital world's reach through communication, speech, and the impact we cannot disdain. Research, innovation, and teaching's might will shine in this lecture's light. The audience shall see the professor's expertise and how it shapes our future flight. So let's listen with utmost attention to this digital transformation's mention, from communication to twinning, a journey beginning, impacting lives, a marvellous invention. So congratulations from the executive and from me. I'm now going to hand over to somebody who is much more esteemed in this subject, Professor Barn. Thank you very much.
Good afternoon, everybody. Good afternoon, and of course, guests, Pro-Vice Chancellor, Deputy Vice Chancellor, Provost, esteemed guests family, I saw wonderful family here. This is a really important day for the faculty. It's a really important day for many reasons, but first of all, for, of course, Professor Juan, who is now a professor, has been for 4 years, as already pointed out, but we're really celebrating today. But it's also special because we can now listen and learn all about digital twins. And I know many of you have sort of recognized this word in some form or other, and it probably is a silver bullet. But that doesn't mean we can't all share this silver bullet, and the faculty is particularly keen to utilize this silver bullet in as many ways as possible. So I want to give you a little bit of background to Professor Juan. I mean, I'm going to call him Juan. I know it's a professorial lecture, but I'm going to call him Juan. I've known him for many years. Juan began his academic journey, Bachelor of Science, degree in Telecommunications in Hanoi, University of Science and Technology. I think some of you will recognize that institution as one of the premier telecommunications institutions in that part of the world. Hanoi is, of course, a really beautiful city. And so he then followed that with a PhD at the University of New South Wales, Australia. And that might have some bearing on the fact that I'm going to relay to you a bit later on. So Juan joined Middlesex in 2011, and that was a point in time where the faculty was really eager and wanting to grow our research activity, particularly in the field of computer science, computer engineering. It was something that we felt we could really make a mark in our sort of environment, in the broader national context, and indeed internationally. So Juan represented one of our sort of key appointments, if you like, and the people on his panel were eager to see how his career would flourish over the forthcoming years. Now, of course, in 2019, he became a professor of digital communications engineering, and of course that title is conferred when you have made a sustained, outstanding, and of course intellectual contribution to the field. In this case, the field of telecommunications engineering. But what do those words mean in practice? And I think for Juan, these mean, in terms of numbers at least, 15 research projects with international partners across the world. And we're talking about India, Vietnam, Indonesia, USA, Belgium. So, you know, it's a really broad spread of countries where Middlesex, through Juan's sort of efforts, is being recognized as a key institution in this field of digital twin or telecommunications engineering. Now, alongside those large number of projects is, of course, research income, and we're talking around about £1.5 million of research income, and a personal accolade, of course, is 130 publications in really top-ranking conferences and journals in the field of telecommunications. So you can see we're talking about a real sustained sort of professorial level activity that we're observing. But as Anne has already pointed out, it's more than just research, it's also about leadership. And I think what I can say about Juan is that there is collegiality and generosity in the sharing of opportunities. That is stamped through his demeanour and in the way he approaches the work that he does in faculty. I don't have any problems in saying that because I have experienced it directly. I think many of you here will recognise that as evidence. You know that it's true because you have worked and collaborated with him on many of these projects. Now, as a faculty, we also sort of around about 2019, partly, well, mostly through some of the work that Juan was doing, recognized that digital twin, I mean, I've described it as a silver bullet, was actually a really important critical technology if we're going to embark on a meaningful Industry 4.0, or if you like now, we're in the Industry 5.0 when we factor in AI, and we've already seen that ChatGPT conversation already. So digital twin was becoming really important for us as a faculty. So in 2019, we set up the London Digital Twin Research Centre, and with Juan as the head of that centre. And initially you could see it as being a way of bringing together some significant work in faculty, but increasingly that centre has built up a national and international reputation now. We have consultations with UKRI. They come to us and say, can you provide advice? So Juan, of course, served on the roundtables advising the roadmap conversations around digital twinning for the UK. So this centre has become important, and I see it playing continually an important role into the future too. Now, I want to sort of just put that aside for a minute and just leave you with two interesting facts though. One, and I think they're in the guide, in that pamphlet, so it's not maybe that secretive. One is, of course, that he is the chair of the Vietnamese Intellectual Society. That, I think, is really important for us as a faculty and for a university, because it speaks to our values of diversity and inclusion, and I think it's fantastic to have that recognised through Juan's sort of role in that body. And the second fact, which I'm pretty certain only a handful of you will know, is that, and I'm going to use that classic phrase of possibly, or maybe, in the Carlsberg tradition, if you get the drift, that Juan may be the only Vietnamese cricketer in the UK who is actually quite good. So I think on that note, and cricket is very important, and which is why he's here. He'll be playing cricket in July, I assure you. On that note, I will invite Professor Nguyen Nguyen to begin his inaugural lecture, and we can all enjoy Digital Twins 101 for everybody. Thank you, Nguyen.
Thank you, Anne and Fabia. You put me a lot of pressure to follow that excellent and kind words of introduction. So let me get Zoom is on. Zoom is on. Thank you. So when we start this, I think about it, and then I felt like, how can I start? What is the topic I can cover here? Because looking at the people, this is the very first time. I'm in front of colleagues, maybe okay, but in front of friends, families, and many different people from the field, I feel like, how can I cover the topic of digital technology and so on? So I decided that, okay, maybe I just tell my story. So bear with me if my story is old and long, and I go through the important milestones, sometimes very personal, but I try to align with the technology development along the way in the center of digital transformation. So let's start from the university that Bobby mentioned. I think maybe 6 weeks ago, Mary, Cookton, and I just standing in the front of this thing, taking photo. Mary's in here. And so we visited Hanoi University of Science and Technology just 6 weeks ago for the business trip in the project work. And this is where I graduated. And even never been to Hanoi, Bobby mentioned the beautiful city. I hope that you will come one day. And so this 2000, May 2000, year 2000, I graduated from the BSc in telecommunication. And so at the time, let's see that, well, you can see here the mobile wireless network evolution. When I graduated, you can see that at the time that is actually started rolling out the 3G mobile wireless communication system. Not yet in Vietnam, but around the world, you see started rolling out that. So let me go back to like 1980s when we got the first generation. We still analog signal. The voice signal we send over the our mobile phone at the time is just an analog signal. You may have the digital for control only. And it is very low data rate at the time. And 10 years later, we started have what we call that the second generation. So it started the digital era. It was still very narrow band. So data rate, you can see the 64 kilobits per second. 1 second, you can send 64,000 bits. If that is data rate at the time, you may remember that a lot of the standard is GSM. So I think that is generated from Europe actually. Europe was leading in that second generation. I think it started from Finland somewhere at the time. So, and then the year 2000, started people talking about the wideband, CDMA, all that technology. This is about that era of 3G, the third generation. So 2 megabits per second, or later on, this updated version 14 megabits per second. You can see that is an upgrade in terms of that. So you can see that if you look at here, at the beginning, 1G only voice channel analog, and then we got the voice and data. So we started to have the messages in the 2G system. And then for 3G, we started talking about multimedia data. You can have the video and web, and guess what? For the 3G system, actually Japan is very strong in that. They are the one that is the first mover in the world. So people follow when they started setting the standard and so on. So Japan was winner actually for the 3G communication system. Right, so Claudia, you remember when did you first use your mobile phone?
Museum.
When, yeah, and what was the model? 2001, even that later than me.
Okay, so it's 210.
So October 2000 is when I started using mobile phone. And a few months after graduation, I worked for a company. I saved some money, and then I started having my first mobile phone. I couldn't remember exactly the model, but it looked like this, a Motorola one. And it's still 2G. It's not 3G at all at the time. Okay, so it's about business transformation. So my first job is actually not in a mobile phone company or industry at all. Actually, I work for television, broadcasting, so Vietnam Television. The company called VTC, Vietnam Television Corporation at the time. So my job at the time, looking back at about that the TV in Vietnam is still analog. You may have heard about all the different standards of the analog television, right? NTSC and SECAM, POW. I think it's Europe. In the UK, you use POW as well, and same in Vietnam. We use a POW system that is standard at the time, analog television. You may forgot that already. Actually, it was like about 23 years ago. That was still analog television signal. So if you are old enough, some very young audience here, I don't know that they know anything about the transformation of digital signal, but if you're old enough, you can see something like this, right? Nowadays in the digital, you don't have this. You got either 1 or 0, a very clear signal or nothing. That is a digital signal. But in analog, you may have something from very good, gradually, graciously, reduce quality until something like this, until you couldn't see anything. So that is about analog signal at the time. But my first TV is not in the year 2000. Maybe you must, maybe Sally was the first TV you watched?
The first one I watched?
Yeah, or maybe you have your own or you
My own
watched.
one.
Long time ago, right?
2001 as well, probably.
So guess what, in Vietnam, when I was a child, we didn't have TV. So the first time I watched TV, actually in the football World Cup, I think 1986. Yes, in the valley, the whole town got only one from the I think, military organization, something. We tried to watch some football matches. But it's all analog signal, very difficult at the time. Right. So talking about analog and digital, I want to go back a little bit technical. A lot of you know already about analog and digital. So you can see here, for example, our voice I'm talking now is basically analog signal, right? So it's a continuous signal in a way, but digital is like discrete signal, 0 and 1, right? And a little bit more complicated if you want that, how we can send those signals to the destination, right, to the receiver. Then you got what we call modulation. In the modulation, you can see that, and trust me, nowadays we still use analog modulation. If you go on the car, listen to the AM or FM channel, audio channel, right, radio channel, you still using analog modulation. So you can see, for example, with my voice signal, it's run like this, and they can use AM modulation, amplitude modulation by, I got one carrier signal like that. And I change the amplitude of the carrier signal according to my voice signal like this. That's how you listen to the AM radio channel, for example. And you may ask, what about FM? Okay, that's about frequency. Then the signal is carried according to frequency. The frequency of the signal carrier change according to the voice signal, for example. But the digital different. You can see that is now bit 0 and 1 here. I either got my carrier signal or I got nothing. So that's how we modulate it. So the bit of that, you may ask what's the carrier? Why do you need carrier? So carrier is just a very simple way, in a way that you can see the sideways signal. Well then, you got three very important parameters, the amplitude, the frequency, and the phase. So we can use those parameters to carry the information. If you change the amplitude, we got amplitude modulation. If you change the phase, we got the phase modulation, for example. Right, so just about that between analog and digital signal in a certain way. I'm not going further than that. So what's the advantage of the digital signal? As I said, digital signal, you have something like between just 0 and 1. For example, my original signal here, right? After sending to the destination, I got some distortion because different things. You can see like this, maybe still look good. This even worse, right? But if I know that there is a pulse like this, I can recover back to the original signal easily, right? But the problem in analog signal, they got a variety of, like let's say, infinite number of shapes. How can I recover back? Which one do I know? So you cannot recover back towards the original one. That's why you suffer something like this. But in the digital one, you got very clear picture. But in the digital, the problem that when the quality goes down beyond the threshold, you got 0. Then it just stops the frozen. Okay, so my first task in the digital transformation journeys, back in the time when I was employed in the television industry, right, is to choose the standard, try to make Vietnam go into the era of digital television. So it's around the year 2000. We have to choose what standard we go for, and how do we go about that in the process. So I remember at the time, I think my friend here, maybe Bill Toya here, one of my friends, he's still here. He working in the same, right at the same university, working in the same company. We work together in this one, just different department. And okay, we have to choose standard. That's my job in my department. Which one I go for? Because at the time, always we got like, American is in one standard, Japan is in another one, and Europe. So Vietnam follow up with the same standard, like with the same power as in Europe. So we can already bias to whatever that Europe going to use in UK example, and that is DVB-T. This is the video broadcasting, right? And then, okay, that's the very first step. I remember that I sent so many emails to one of the experts in the UK here. I only remember his name is Barry, but I lost contact since then. Not our Barry. Asking all the questions about digital television standard. He said, what is this guy about? He's from Vietnam and he's asked so many things. But that all where I started. But how do I help with Vietnam to select the right standard for the digital televisions? And you know what? Even we chose the standard, it's when we didn't finish there. We have to follow up with what's the next step, because we got thousands of the transmitter already around the country, right? And they are all analog. So we have another job in that. We have to redesign the existing analog transmitter for digital transmission. You cannot just replace with a digital transmitter. That's so difficult. And part of our job in that, okay, I'm not going to detail exactly what we did, but a lot of things in this transmitter, we have to remove them. All the analog video and audio modulation, remove them. We have to change a little bit of filter here and there and so on. And to make it work, it did work, because we installed ourselves in our near office, everything, and then make it work. And at the same time, we know that the television sets, they are analog as well. How do we make them digital? Okay, we have to design a set-top box. So this is the one can receive digital signal. But then bring this analog signal back to the existing TV. So we produce this, sell this, and make money as well. That's the thing at the time. However, you can see here, that the process in the year 2000, you see that is my team job. I contributed to that. But here it's just, that everything happening after that, which I may not involve. Why? Because this is the reason. When I try to understand about the digital television, the technique and so on, I remember I read this paper. A lot of my colleagues would know his name. Hikmet Sari. I think he worked in France, and then I think he moved to China. But he wrote this paper. I read again and again and again. Many things I didn't understand. How does he make conclusions like that? How can he have to provide evidence and simulation and so on? Basically, that he argued about two things. Okay, I go a little bit more technical. One is that the technique we call OFDM. Basically, you multi-carrier. With another technique they use that is just single carrier. But you have to deal with frequency domain equalization. I may not explain what the frequency is. But basically they said that there are two things. And there is one bad thing about this, one good thing about this, basically. He saw every conclusion, but didn't show how. And I didn't understand. I said, there's so much I need to learn. And I decided about time I leave the company. About time I leave Vietnam. I left Hanoi behind, I left my girlfriend behind, and I go to Sydney. Hello, Sydney. Wow. Okay, so you see that I prepare to spend the next 3 years in this corner. This is the corner. I was doing this. Look at the monitor at the time.
In that Windows 95?
Yeah, 2000. I don't know exactly when that, but it's that around the year 2000, 2003. You see that, but you go to Sydney, excited, you look over the window and you see this. Can you focus, can you do anything? And then I decided, oh my God, I just enjoy Sydney. It's a beautiful city. And listen, for the first 3 months, I did just this. I just enjoyed it, everything, and then, you see, in the city, you see that even the Christmas time is the summer time. So you go to the beach, you enjoy it, and everything. But then, you didn't define the research program. The first 3 months you supposed what is the research program? Can you show me? Can you tell me? Okay, so I realized straight away, okay, I need to refocus, and I realized that doing PhD, I keep telling my PhD students now, if you enjoy life during the PhD, you will suffer later. So you should suffer now and enjoy life later. So I get back straight to work and go back to the routine. So at the time, the world wasn't waiting for me to enjoy life. The full swing research on the 4G technology happening around the world. You see that? I know that it's 4G at the time, rolled out in 2010, but it's my time, 2003. It's full swing of research ongoing in that. With the technology, we call long-term evolution. And one of the key important things, MIMO and OFDM. I keep saying this word because I'm coming back to that. One of the two key technology at the time, but still now, even now, in all the Wi-Fi system, everything here we are using now, or our mobile phone, they use those technologies. And people still researching on that to see and the improvement can still be done. Okay, so with the 4G, let me go back to that. The 4G actually officially rolled out in the year 2010. So you can see that roughly every 10 years, you got one generation of mobile phone system. You can see around every 10 years. So this 4G technology, the data rate you can see up to 100 megabit per second, and later on even 1 gigabit per second. This data rate, I tell you what, is a theoretical data rate. In reality, maybe a lot less. Okay, so the target of 4G system is that we can support multimedia streaming, video conferencing, TV with high quality. And I tell you what, ADSA invested a lot on this. They probably was the leading country in this technology. Okay, so going back to that, I want to back to my research. Actually, when you do research, you always need to have reference. And he's a man, maybe a lot of you know about him, Shannon. He just wrote one landmark paper, 1948. You may have read them already, right? I keep the reference for us to see. He gives us that, okay, everything got a limit, everything got a certain capacity, which you cannot go beyond. So here is his capacity. You can see this is a slide. You cannot go beyond that. Nothing exists in the other side of that line, that curve. You need to go around here, and because I tell you this is the limit. Any communication channel got what we call the capacity, the stability. If you go beyond that, the system wouldn't be able to work in that way. You can have a lot of error, a lot of the things that are not reliable. So that's what he said. But the problem with all the genius people is that they just tell us what can be done, what's the limit. They never tell us how can it be done. You just think, okay, I know this is the limit, but to find that limit, you have to go and find it yourself. I'm not going to tell you. So all of us just trying to, okay, maybe we are here now. Can we approach and maybe design some of the new coding scheme modulation to get close to this line, close to the limit? And part of our research is doing just that. Okay, so what do they do? I focus on the technology I call the orthogonal frequency division multiplexing, a little bit technical, but I just want you to remember the keyword orthogonal. That's just that, orthogonal. In communication, we care a lot about, we obsess with orthogonality, everything like that. If you are being orthogonal to each other, you don't interfere with each other. That is the idea. So in here, the idea is that coming back to that, the single carrier system with the OFDM is a multi-carrier system. Okay, going back to digital television, you got even that 2K or 8K mode, 2K maybe around 2,000 sub-carrier, 2,000 carrier, 8K even 8,000 carrier, compared to the single carrier system is very different. So the idea you can see here, like if you just single tap like this, or you multiple stream like this, if this one broken, then you are done, right? But if it's one too small tap like this, it's broken. We still got some water coming out, right? That is the idea. And similar to the truck company, if you go all in one truck, what if this truck broken down? Then that's a problem. But in here, I divided into multiple smaller trucks going parallel. One truck break down, that's fine. Let's keep the other ones keep going. That isn't better. So that is the same idea with OFDM. But another thing in OFDM that is much better is that, okay, I'm coming back to the keyword orthogonal. If you got the sub-carrier like this, okay, 1,000 of them, but they are being orthogonal to each other. They will not interfere with each other. That means they can live with each other. So in this way, you can squeeze everything in like this. It's very efficient way. Whereas the traditional one, you have to go one and then separate another one. It's not very efficient. That's another reason to make it that the system much more efficient. And that's why you can increase the data rate. And that's why even now, all the advanced modern communication systems using OFDM. The Wi-Fi we are doing here, using OFDM. Mobile phone we have, using OFDM. Okay, so maybe I skipped a bit, but the idea of that being orthogonal, you can see that 1,000 of sub-carrier like that in the graphical way. And why we are being to over there, it's just, that's the idea. Okay, so in wireless system model, I try to explain a little bit a simple way. Okay, you got the transmitter and receiver example. You want to send from here to here, the data signal, right, information, and you have to go through the channel. If normally we got the system model very simple, the receive signal with the channel here, and this is our information, the data, right? Always got the background noise. This background noise is the annoying thing that because it's random. So it is always add something to the system that makes it hard for you to recover the information you want to recover, right? So myself add the PSD program as a caveat. Okay, either if you want to detect this information, you need to know this channel at least. Otherwise, how can you detect? I don't know this, that's still okay. Maybe I find a way. But if you don't know this, it's quite difficult. So, but to know this, how do you know this channel? Because the channel is here, quite difficult. So you got the job of channel estimation. To estimate that, you have to send something first here. It's a known signal. If you know this one, you can estimate this in a certain way. So once you know this, you're going back to that, okay, I'm going to detect this one for the next time slot, for example. But that is all the job I did, but I use different techniques. The technique is the iterative design, because you know that in life, if you know the turbo principle, I think like in car, turbo engine, if you use the output of one component, get back as the input of the other component, after a few iterations, the performance improves. It's similar here, the turbo principle in signal processing in communication system. You can see, first iteration, not very good. Second iteration, improve a lot. But then it always follows what we call the law of diminishing return. You cannot have any more if you get conversions. So, and normally I ask industrial expert or friends, they say that just stop up to one or two or three iterations, you cannot go anymore because of the complexity. Right, so the application, as I said earlier, a lot of the modern communication system, we use OFDM, wireless LAN, LTE, 4G, 5G, in broadcasting, and so on. But it's just not about the OFDM. Another techniques that I study at the time, I investigate is that, okay, if you look back at the other model, only single antenna, but we can have multiple antenna. If you look at maybe sometime in our room here, we see the access point, we see two antenna. That's another example that we can use more than one antenna for that. So you can see if we use more than one antenna, the channel become more complicated, become a matrix like that, right? From one antenna can go to the other receiving antenna, and so on. So it becomes a matrix of that. Okay, which means that thing gets more complicated. The signal gets more complicated to separate as a receiver. So what's the advantage of using this kind of concept, multiple antennas? I call that in multiple input, multiple output, MIMO. You increase reliability or you increase the data rate. Okay, so there are research saying that you cannot maximize two things at the same time. If you got the best of this, you suffer this, and the other way around. And there are always trade-off between the two. So I investigate both of them, starting from this one first. My design is in a very simple way. I try to explain to you like this. Why we got what we call increase the reliability, increase in the term of what we call diversity gain. You can see here if I got multiple antenna, right? I just repeat all the channel with a simple example, across antenna. So if this channel condition in a not very good condition, example, I got a chance that from this guy will come into this is a better condition. Because that provides diversity. Because they are independent in a certain way. So that's the diversity gain you achieve. Okay? But repeating like this may be not the best solution because you may be wasting resources. You don't need to repeat all the time like this. So I think my simple solution after some, of course, months or even year of investigation, we end up with the solution of in diagonal like this. And you want to go more detail? Maybe you need to read this paper. I didn't move to Canada. I didn't study over there. I put this picture here because another milestone. Everything going well with research and so on, but then I got invited by my supervisor. At the time, he was doing sabbatical leave in this university. So he invited me to come here for a few weeks, for a month, doing some research with me, and enjoy Canada. Okay, so I went there. The flight was horrible, 26 hours. And I was sick before flying actually. And so it's horrible chances in California and then fly and so on and all the things. I come back the first few weeks, very good, very productive because we finished one journal paper at the time. I really enjoyed it. The last day when I leave, you know what? He told me that, well, no more is just start writing up. So this the thesis, the report. I said, what? I still got more than 1 year left in my scholarship. Why I need to study up? My PhD program at the time only a little more than 2 years. Why he told me that start writing up? I don't feel I have enough result. And I need to do with the mind more detection. I still haven't done that. I need to do more. But I'm going to leave Sydney. I'm going to leave that university. I'm going to leave Australia. And you need to graduate. And he told me that. Oh my God. Oh. I didn't know what to do, what to react at the time, so I had to fly back anyway. I came back, I think about that, I said, okay, maybe I will buy some time. I need to work hard because he's still staying in Canada. He's still staying there, helping, of course, still helping and everything. I said, okay, maybe even during the writing mode, I can do some research. So my message for my current business student in this room, or maybe over Zoom, is that in the last 6 or 8 months, if you really focus, got a purpose, you can be very productive, you can do so much more. And that's what I did at the time. I did that with the threshold that you have to graduate within that. Otherwise you're going to leave and everything, and then I deliver. So it's the same message for my current student. This last 6 months, 8 months, so important. I just want you to focus on that. And I managed to graduate, yes, at the time. And there's still some scholarship time left, actually, with that. It's a graduation. And I tried to order this from Australia, but we never got this kind of version from there. It's quite far away. Doesn't matter. Okay, so after graduation, I enjoyed a couple of months in Australia and officially got the degree in early 2007. Then I say goodbye to New South Wales, and I hello Old South Wales. I swapped Australia with Wales. I swapped Sydney with Swansea, and Bondi with Mambo Bay.
How about your girlfriend?
Yes, so my girlfriend, and then at the time, you know, that nothing changed from this move, except the weather. And my girlfriend became my wife. So can you see the thing that, as I said? So the first day we came to the office in Swansea, my line manager said, "Oh, look, it was rainy day. It's really bad, raining." And he said, "Look, this is a perfect environment for research. You never need to go out. Just stay in the office and do research." And I think he was right. By the way, one of these photos was created by OpenAI. Can you guess which one? Okay, I'll leave it for you to think about that. But I couldn't find the photos. I asked OpenAI, "Can you create this for me?" And then it's very accurate, actually. Right, but as I said, things remain the same for me in terms of research. I carry on with doing MIMO detection and so on. But this time I do not focus on increased reliability or diversification. I want to increase the data rate. What does that mean? That means that all the antenna here, I want to utilize that for a symbol, different symbol. If this one symbol, different one, I increase the data rate because they are different information, right? But the problem is that how can you separate them at the receiver here after this careful matrix? And that's what we call MIMO signal detection. Right, so what did I do with that? At the time, I got a company called Huawei from China, if you know that, right? They are ready to give us some funding in the condition that, okay, you have to design some of the signal detection near the optimal performance, or we call maximum likelihood detectors and optimal performance, but at the complexity of very linear detector, like minimum, mean square, or zero forcing, if you know those things. I said that, what? He paid that at the rate of a Vauxhall car, asking us to buy a Ferrari, which is not possible. But we say that, okay, but we're desperate for funding anyway. Let's do it. Let's do it. So the solution, we think about two things at a time. It's a lattice reduction. If you know about that, in communication here, ignore the noise at the moment. If the AB, okay, A is channel, B is our information, right? If you look at the whole lab, you can see that as in terms of the lattice or the point here, right? So the lattice always can have what we call that is the basis, the lattice basis, which is the A or the A bar here. Now, the idea is that if my lattice, the basis factor in A over there, in the dark channel A, is in very bad condition, something like this. I call it very bad because we want it to be orthogonal. Again, in communication, we like things to be orthogonal. It's easier to separate them. They don't interfere with each other. That is the idea. So can we convert something from this to this? Okay. So shorter factor, but being orthogonal as well. Keep the same lattice point here. We don't change the lattice point, right? So in that book we call lattice reduction algorithm. So that's what we did at the time. And the only problem that how do we move from A to A bar like that, from here to here? It's not easy either, and the complexity is always a problem. But we managed to do that. Performance still not at the Ferrari level yet. So we add another ingredient. Okay, how about that? Maybe we suffer a little bit about complexity, but we increase performance a lot more with what we call the list-based decoding. So in general way, when you choose the detection that you got the receive signal here, you choose the closest one only. But now I do not just choose single one. I choose somewhere around that as well to make sure that if I make a mistake for this guy, then I still got these three guys to cover for me. The performance is much better. So the combination of the two of them make us very successful. And now you can see that Huawei happily to get all of this and move that to the implementation department and also get the patent on this. Of course, our name is in there as well. But that is some of the story I want to tell you and still relevant now with this technology. 2011, I joined Middlesex University. So happy with that. And you can see that, okay, this is the quadrant just down there, isn't it? And when I moved to Middlesex, I think about it, it's just not about individual work anymore. Maybe that's right. It's not about individual work anymore. I need to have an identity. We need to work together. We need to build a group. So you need to have an identity as a group. So that's what was started as maybe many in our office D115, our college here, right? We together, we build a group, we say that is a 5G IoT research group. At the time it doesn't have the 6G name on that, but just recently we had to add 6G to make it relevant. Ma'am is smiling because he recognized this photo, right? It was a photo in one of the trips from the group. We went to Turkey, Cyprus, to meet with the partner, project partner, Middle East Technical University. So it's a beautiful view just in there. And so we founded this group.
That's right. That's North Cyprus.
Yeah, the Northern Cyprus, yes. But then, around the world, things still keep happening with the technology. So now people started talking about the 5G technology already at the time. Okay, they want to have a lot more higher data, a lot more data rate. So we see that 10 to 20 gigabit per second. So we are talking about the fifth generation. Of course, now we know that it has been rolling out from like around 2020 or 2019. But at the time, around 2012, we started doing a lot of research on this. You can see that the technology we are doing on still advanced MIMO technology. Some OFM still doing. And for the millimeter wave, network slicing, edge computing, all that kind of technology we did. Okay, so in 5G, what is this for? Remind you that even 5G now, we haven't used full potential of 5G technology. It's still at the early stage, actually. Still, but the rolling out has been happening all around the world. Okay, so we are talking about the services or maybe the use cases they can provide that they can support virtual reality, augmented reality, video 360, massive IoT, smart edge, the smart city or smart anything you want, smart factory or communication. And they target now the autonomous driving, robot surgery. I have to say that China and USA, they invested early, especially China. They invested a lot on this, so they probably leading in this race. Okay, USA doesn't like that. You can smell that, and a lot of governments that just ban some of the equipment from Huawei. There's a thing going on like that. Okay, so in 5G, there are 4 major applications. You can see that we support. What I meant is that you want to have autonomous driving. What we call that, you need to support critical IoT. So you need to have the delay reduced a lot more, almost like real-time communication, right? And you need to support massive IoT. So in the smart factory, you may have thousands of the sensors. You need capability to support that kind of communication. And of course, as a way, you use mobile phone, right? You need to always have higher data rate. You can have stream mobile phone. You can see that everybody using mobile phone now streaming at the same sport event, for example. So the system needs to be capable of doing that. So that is the target for 5G. Okay, so here's a little bit detail. I may ignore this bit. And with all the potential market over here, this is this figure I just keep in here. We skip them, but I know that the potential of 5G is huge. And the ones knowing that the country lead in 5G technology, maybe leading the world in a certain way in there. So, and China and the United States always is a leading country in this, invested a lot of money and doing things early. Okay. And rolling out, I think that as I said, that is the country leading like the first, USA, China. And then after that, we got Japan, Korea, Singapore, then we got Europe as well, following that. What about in the UK? I think the UK started rolling out 5G from 2019. The delay actually a little bit with, as I said, the government is not very clear in the guidance that whether you are allowed to use Huawei equipment, whether you have to remove them actually, because some already existed in them, in the system, and they have to say, oh, you have to remove all of them because of security, national security matter and so on, right? And at the time, that also delayed the rolling out of 5G in the UK. But finally, you can see that all the CTA has been done some time ago. Going back to our group research, what did we do? Well, now as a group, we did a lot more. I cannot go through every single detail because there's so much technology going on, like the relay network, but I want to mention that a few names here. You can see that our colleagues in the T1 Tuan, and Dirk, you are here as well. All that, Ali, I think maybe Nana, you are here. We got our student Ali, that I don't know where he's in now, but we got a lot of the, so maybe all this name or the thing I want to acknowledge that actually Tuan is my first PhD student, now is my colleague. Kamran is my PhD student, now is colleague here as well. So for that's some of the good things that I can see from there. And also that maybe Jiang, you are here, or he's gone. He's a postdoc, but he moved on to the University of Surrey. Musin, if you are on Zoom, I mentioned your name because you play cricket as well. I know that.